Hello everyone. In this video, we are going to explore a new feature of LuBan. It's called hash surface. It is an add-on to the existing hash method. At the beginning, I got the idea of hash surface from a picture shown to me by a good friend, Steffi. She showed me this picture and I was really surprised about how people can make this kind of structure. There are two things that I was surprised. Number one, how are those panels assembled? As you can see, it is a bit similar to the plate method that we have in LuBan. We have finger joint on the edge to assemble the structure, but this structure is different. On the edge, there is nothing. It's purely touching edge. Number two, I'm curious about what was the dot at the center of each triangle. So I digged a little bit on the internet and followed a link shared with me by Steffi. I found this article talking about a structure made from laser cutting. So I scrolled down to this page, then I realized that the author of this method might have used a similar technique as hash, creating an interlocking structure in the interior of the model. So these are horizontal plates and these are vertical plates. You can interlock the horizontal and vertical plates on the interior. And what is a bit different from our hash method is that it not only has the slots for interlocking, it also has bumps on the surface for fixing the surface panel or fixing the hash surface. And that's how it is assembled. When you assemble the vertical and horizontal plates, you will get this kind of structure, quite similar to hash, but on the surface you have the bumps. Then taking all the triangular plates and hammer them onto the bumps. Of course, the tolerance has to be fine-tuned so that you get a tight fit, not a loose fit. After reading through the article, a very helpful article, then I have an idea about how to modify this to work with LuBan. And let's start. Open LuBan software. And then open any STL file. I prepared an egg STL file just to show a similar example as what you can get from the PDF document previously. Go to Mesh, LuBan, select the unit. I selected millimeter, and then set the method to hash. That gives you a hash structure that you should be familiar with already. I'm going to turn off the text. Or maybe I'll leave it on for now. The control that is newly added is the surface control. By default, it is no, so you get the old hash with the skeleton of the structure. If you set it to yes, you will get all the surface panel. Okay. As you can see here, the hash style is orthogonal. You get all the skeleton parallel to z-axis, parallel to xy plane, and yz plane, so it's parallel. If you set it to radial, you will get a radially spanned hash, and then turn on the surface, you will get this kind of structure, similar to what we get from our initial example. But due to the coding difference, I preferred the quadrangle surface patch in contrast to the triangle surface patch. All the other controls are the previous controls used by the hash method. I did not add any other control except the surface option, yes and no. You can increase the number of layers. You can increase the number of Z layers as well. In addition, you can set the tilt angle. You can tilt it. And when you tilt the angle, sometimes you will see one or two, a few pieces that couldn't be assembled nicely. That may happen. If I set the tilt to a different direction, you get this, okay? And when you assemble them, you basically take each plate, surface plate, and hammer it onto the surface bump. You can click Object Explode or keyboard shortcut E to explode and see inside. Where is it? This is the surface bump that's created. When the surface option is set to no, the surface pumps are not generated. Again, we have a critical parameter that controls the fitness, and that is tolerance. If you were to produce these by 3D printing, the tolerance has to be a negative value. As you can see, it reserves some space in between the gap for the material expansion. When you 3D print all these parts, the material will be expanded. But by default, the hash method is more suitable for the production of laser cutting. And in laser cutting, you need to use a positive value, 0.1. So on the display, it will be a very tight fit. But during laser cutting, the material will be burned out. A thin layer of material will be burned out. So the seemingly very tight fit in practice will be a good fit. You can hammer it into the pumps. My last few words about this method is this method works well for regularly shaped structures such as cube. Maybe we can try a cone frustum. For this regularly shaped model, this structure works quite well. I'm going to set the tilt to 0. Okay. However, if you use an organic model, you will get some of the surface patch that can't be assembled. I'm going to set the model to a bigger size. And for this model to work, for this method to work well, you have to use a relatively small sheet thickness, relatively thin sheet. If you use a sheet thickness of 10 millimeter, you better have a model maybe about 1 meter tall. Turn off the text size. You see, this is what you get with an organic model. For this model, the radial center is here. It is not on top of the duct. And I can change it slightly. The radial center, I can change it to 0.15. I've tested it before. This will put, okay, this is putting at the back. So I'm going to set it to negative 0.14. And then that's the radial center. I moved the radial center from the center of the model to the center of the head of the duct. As you can see, not every piece can be assembled. These pieces are fighting on the same space, so they can't be assembled. But that's it. For a regularly shaped model, the surface option of the hash may work quite well. Thank you for your attention.